We'll do one more derivation involving the inverse trig functions, and this last one is going to be the derivation of the derivative of tan inverse. So if we have here the equation y equals tan inverse of x, we want to find dy dx, we want to find the derivative of tangent inverse. Just like all the rest, we start by taking the tangent of each side. So we have the tangent of y is equal to the tangent of tan inverse of x. And so this, of course, the tangent of y is just that. And the tangent of the tan inverse of x is x, again, because of that inverse relationship. So now we'll take the derivative of each side with respect to x. So the derivative with respect to x of the tangent of y is equal to the derivative with respect to x of x. And remember, y is a function of x. Y depends on x, so we have a composite function. Tangent of y, tangent is the outside function, y is the inside function. Using the chain rule, we'd have the derivative of the outside function. The derivative of tangent is secant squared, evaluated at y, at the inside function, times the derivative of y is equal to the derivative of x is 1. This should be getting to be kind of familiar stuff by now. So we're asked to find dy dx, so I'm going to write the derivative of y as dy dx is equal to 1 over the secant squared of y, and that is dy dx is equal to 1 over, well, let's see, this is the secant squared of y was the tan inverse of x. So we have that. Now we just need to rectify this situation. What is the secant squared of the tan inverse of x? And remember that in this case we have this angle that's the tangent inverse of x, we'd think of it, and the tangent of that angle is equal to x, or we could think of it as x over 1, and the tangent is the ratio in the right triangle is opposite over adjacent. So if we let the opposite be x and the adjacent be 1, well then, remembering the Pythagorean theorem, a squared plus b squared equals c squared. All right, the adjacent a is 1, so we have 1 squared or 1 plus the opposite x squared is equal to c squared. So c is equal to the square root of x squared plus 1, or 1 plus x squared, however you want. All right, so this side, the hypotenuse, is the square root of x squared plus 1. So now notice then, in this case then, that the secant of the tan inverse, well, the secant is the secant of this angle, and the secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. So the secant of this angle is the hypotenuse, square root of x squared plus 1, all over the adjacent 1, or just the square root of x squared plus 1. And I wrote it that way because we remember we have secant squared here. So secant squared, just squaring that secant, is going to get rid of the radicals, and we'll have 1 over x squared plus 1. 1 over x squared plus 1. Notice that's always going to be positive. The denominator is at least 1. That's always positive. Here's the part of tangent that we invert to get tan inverse. Okay, from negative to between negative pi over 2 and pi over 2. And then here is the inverse tangent. Notice always positive, always a positive slope. The slope is the biggest when x is 0 because the denominator is the smallest, and the slope is the smallest out at the ends where x is very big and the denominator will be very big. So we have then that the derivative with respect to x of tan inverse of x is equal to 1 over x squared plus 1. A list of all 6 of these inverse trig functions can be found in your textbook.